number 40, section 4.2. This is on page 198. It shows we need to prove that the zero vector in the vector space is unique. Okay, every vector space has a zero vector, but from the definitions and from the axioms, it doesn't say that there's another zero vector, there's another vector who behaves like the zero vector. It doesn't say that. So what we want to do here is to show that there's only one vector that behaves like the zero vector. That's the exercise. Okay. So if we have two zero vectors, then we can show that one has to be equal to the other. So let's suppose there are two zero vectors. So I can make my notation to be, here's zero vector 1, okay, and here's zero vector number 2. So eventually we'll see that they must be the same. Okay. Well, if this one here is a zero vector, then that means if I pick any v for any v in the vector space, if I add v plus the zero vector number 1, I get the vector back. Okay. So that's how the zero vectors behave. And also, because this one here is also a zero vector, so it would do the same thing. If I add a vector plus that zero vector, I get the vector back. Okay. All right. Well, how we show that this one is equal to that? You cannot just say, well, okay, they behave the same way, they must be the same. Well, that's what we want to show, right? What we can do is to actually substitute this. See, v here. V is equal to v plus zero vector 2. So let's substitute that in here. Okay. So that's what we have. Now, to get zero vector 1 equal to zero vector 2, what we can do here is to add the additive inverse to both sides of the equation. So we add the additive inverse to both sides of the equation. Okay. Now, when I do that, v plus its additive inverse is a zero vector. Now, it could be any of the two, doesn't matter. So let's say is the zero vector 1, it could be or 2, okay? It doesn't matter which one it is. If I add, I should get the zero vector back. And then plus zero vector 1, okay? So I'm adding this here. So it's equal to this one here, okay? And I'm just repeating the other part here. And then equals to, now here I'm going to add these two. So what do I get here? Well, I got a zero vector. It could be one or the other, it doesn't matter which one it is, okay? And then plus zero vector 2. Okay. Well, now, since this is a zero vector, if I add zero vector to any other vector, then I get the vector back. So adding that to this is the same as ignoring that, okay? Ignoring this. So I get zero vector on this side, right? And then this is zero vector plus this thing here. I get that back. So that's the end of it.